Hi, class. Today's point of emphasis for our Q&A is going to be actually looking at how to construct and understand frequency tables for a set of data. And I'm going to talk about what a relative frequency is and what a cumulative frequency is. So, like a frequency table is just a table that displays the number of occurrences of each unique value of a range of values within a data set. That sounds really complicated, but to simplify it for you, if I'm living in a house and you have three dogs, two cats, and a bird, dogs repeats three times, cat repeats two times, bird repeats once. And it doesn't matter what order you put it in. If you walk into the house, first thing you see is a dog, it gets to count one. Then you see another dog, now the count goes up to two. Then you see a cat, that goes to one. Then you see a bird, that goes to one. Then you see another cat, goes to two. You see a dog, goes to three. Like that's usually what happens as you're collecting data is like you're getting these values just in any order. And so when you conduct or construct a frequency table, what you're now doing is you're looking at what values you get, in this case, or example, cat, dog, bird, and now you're just counting up how many times each one repeated itself. So at the end of the day, it's just three dogs, two cats, and a bird, even if it came out of order. So you kind of almost put things in order when you're putting together a frequency table so you can do that count. And that's how you're going to report it back just in a table. So pretty basic stuff, not that complicated, but it does confuse students until they like actually just start playing with it. Um, Relative frequency, that's just looking at like the frequency value over the total number of observations. So if you got three dogs and there are six pets, it's 3/6. If you got two cats and there's six pets, it's 2/6. One bird, six pets, it's 1/6. So relative frequency is just basically looking at the frequency of one particular data count, that value, and it's dividing it by the total number of values present. So relative frequency is pretty straightforward. Cumulative frequency isn't going to necessarily work very well for the example I gave, but it would be like looking at the running total up to a point. So if I walked into a house and I encountered a dog and then a cat and then another dog and then a bird and then another dog, that still adds up to three dogs, two cats, and a bird. But what if I'm like going through the house and halfway through the house I stop looking for pets? So I end up with a dog, a cat, and a dog. So if I just look at the data up to that point, it's just two dogs and a cat. It's not going to be three dogs, two cats, and a bird if I were to do the whole house. So a cumulative frequency is kind of like stopping your count part way to a point. It doesn't have to be halfway like I just did in my example. It could be a third of the way, it could be 10% of the way, it could be 90% of the way. But sometimes something like that really helps. So, like, where does this fit into nursing? I mean, if you got a data set representing patients that vary in age groups who visited a clinic over a month, a frequency table could show you the number of patients in each age group. Say you have an age group of 0 to 10 years, an age group of 11 to 20 years, 21 to 30, and so forth. You could see the relative frequency of each age group that are coming to the clinic over that month period and determine, are you slanted toward older patients, younger patients, maybe patients in the middle? Maybe you're not slanted at all. Maybe it's kind of equal all the way through. But a frequency diagram could give you a quick idea of some things about your data. So that's where you might encounter it in nursing. I left a resource link in this post, so be sure to check that out. And hey, thanks for watching, and I'll talk to y'all later.